dear students, the logic in plain terms is pretty simple. Take a temporary variable, empty any one of the contents. After that, now that x is free, put in y. So therefore, now y is free. In y, put the old value of x. The old value of x is stored in temp. So therefore, this is how you use a third variable, or people also call it as using a temporary variable. You use a third variable and swap your values and swap to numbers. So this is how you use a third variable and swap your numbers. This forms basis for a lot of mathematical logical operations. Swapping is a basic part of many sorting techniques. Many sorting techniques works on the concept of swapping. So therefore, without swapping, it becomes almost difficult to sort a large set of numbers. So this is one of the methods in which you can swap two numbers. So this is logic number one. And now let's proceed to see what is logic number two. Because we are talking about numbers, numbers can be added and subtracted, isn't it? I hope everyone agrees to this concept of yes, numbers can be added and subtracted. So let's take and try to see method two. How does method two work? Okay, let us assume that x is 5 again, and let us also assume that y is 10. Okay, now let me just write this instruction. Please just go through. I'm summing up x and y, but again storing it in x. So what does this imply? What does this imply? Please just see. Summing up x and y, but storing in x. So therefore, what is x? What is x? 5. What is y? 10. What is 5 plus 10? 15. Where am I putting 15? 15 is again kept in x. 15 is again kept in x. So I'm putting in x the value 15. This operation puts the value 15 in x. So now x is 15. Now I want, because x is modified, I put y is equal to, what is the value of x? X is 15. So x is 15. The current value of x is 15. So therefore y is equal to x minus y. Just tell me, what does this do? Try to understand. What do you think this will do? What is the value of x? The current modified value of x is 15. X is a variable. So you're trying to put it to y. What is that you're putting to y? X minus y. X current value is 15. So 15 minus y value. What's the y value? Y value is not modified. It is 10. So what is 15 minus 10, friends? 15 minus 10 is 5. So therefore, y stores the value 5. Now, again, because y got the value that, y is swapped, but x is not swapped. So just make x is equal to x minus y. What does this imply? This implies again a similar kind of thing. So therefore, y is equal to x minus 5. What is the x value? X value is still 15 because x is not modified further. You're trying to put it in x. X is equal to, x value is 15 minus y value. What is the y value? 5. The recent modified y value is 5. So what is 15 minus 5? 15 minus 5 is 10. So just check out what at the end of this operation, x is holding a value 10 and y is holding a value 5. Didn't it get swapped? Yes, it does. It did get swapped. So therefore, what do you call this as? This is another logic that holds good for numbers to swap. And this is swapping of numbers without using third variable. So this is swapping of numbers without using third variable. So this is a logic which we try, to swap without using a third variable. This is how you initially progress. Okay, x plus y, summation in one number. That number I'll minus from the second number. So therefore the value got swapped. Again from the summation, remove that modified number so that their values get automatically swapped. Hope this makes sense to all of you. Hope this is clear. This is very, very important. We generally in coding prefer writing, temp logic only. Generally, whenever we swap, we ensure that we swap only using a third variable because that looks pretty simple and small. But yes, even this is all the possible ways of solving it. Okay, so then we come back to the third question. How do we generally swap two numbers? How do we got to swap two numbers using bitwise operators? So if the third question is how do we swap numbers using bitwise operators, then we have to decide and probably realize that there should be another way as well of swapping two numbers. So swap using bitwise operators. So what is the job of bitwise operators? The job of bitwise operators is to, yes, the job of bitwise operators is to operate on bits. So again, we follow a simple logic. Again, let's say x is 5. Okay, and because we are habituated, let us say y is 10 or whatever it is. If you're okay, we can make y as 10. Okay, x is 5, y is 10. Because we're okay with this example, let us write a logic. X is x exclusive or y. Now, what does exclusive or do? Exclusive or is an odd function which which gives 1 when the bits are different and gives 0 when the bits are same. In a particular thing, in a particular number, when you're trying to apply exclusive or on two numbers, two binary bits, if both the bits are similar, it gives 0. If both the bits are different, it gives 1. So there's a logic that we got to write here. We'll understand what that is. X is equal to x cap y. Okay. So then again, y is equal to x cap y. And again, x is equal to x cap. Okay. Let's just take a minute and try to understand what this is. Okay, so let's just take a minute and try to understand what this is. So what do you mean by this? Let us now write it. What is the value of x? X is, okay, here we'll take it. We'll try to solve this third example in this part of the corner. So yes, we are trying to see an example. How do you take it? What's the value of x? X is 5. What is 5 in binary? 101. Okay, 5 in binary is 101. Because I'm taking 10, I just put it like this. What is y? Y in binary is x is 5, 5, which is equal to 101, and y is 10, which is equal to 8 plus 10, right? 8 plus 2, right? 10. So 8 is 1, 1, 0. If you want to audio bits, you got to have some space. So therefore, it is okay. 1, 0, 1, 0 is 10. 1, 0, 1, 0 is 10. Now, what are you going to do? You're going to do an operation called x cap y. So x exclusive or y is your logic. What is the answer of this logic? X exclusive or y? It gives 1 if the bits are same. So what is 0 or 1? 0 exclusive or 1 is 1. Next, what is 1 exclusive or 0? 1. What is 0 exclusive or 1? 1. What is 1 exclusive or 0? 1. So the answer is 1, 1, 1, 1. What is 1, 1, 1, 1? 8 plus 4 plus 2 plus 1. 8 plus 4 is 12. 12 plus 2 is 14. 14 plus 1 is 15. So you got the answer as 15. So what is 15 initialized to? What did we initialize 15 to? We initialized x is equal to 15. That's what we did. We wrote in the first line, x is equal to x exclusive or y. So therefore now the x value is 15. Go back and do the second line. What is the second one that you got to do? The second line of the expression is y is equal to x cap y. X cap is also called as x exclusive or. So now what is x value? 15. 1, 1, 1, 1. Exclusive or. What is y? Y is 10. 1, 0, 1, 0. Tell me the answer. Try to OR the bits, exclusive OR the bits, 1 and 1 or 1, 0. Okay, if you're not comfortable like this, you can directly put the things, but I'm just looking at here. So this is 1 or 1, 0, 1 or 0, 1. Again, 1 or 1, 0, 1 or 0, 1. Yes, so therefore I got my answer. What is 101? 101 is nothing but 5. You can just check up. 101 is nothing but 5. So therefore, 5 is stored in what? You're storing all this in what? You're storing all this in y. So y is equal to 5. Did you get the value y is equal to 5? Yes, we did. We did get the value y is equal to 5. So when we got y value as 5, now it's time for us to go back and check out by step 2, y value is 5. By step 2, y value is 5. By step 1, yes, by step 1, x value is 15. X value is 15. Now we are looking at step 3. So how do you proceed with step 3? What is step 3? Step 3 is x is equal to x cap y. That implies, what are you doing? What is the x value? X value is 15. 15 is 1, 1, 1, 1. Exclusive or y. What is y value? Y value is 5. It is 0, 1, 0, 1. So what do you think is the answer? You're putting it in x. What is that? You're putting it in x. What is that? You're trying to put it in x. 1 or 0? 1. Next, 1 or 0, 1. 1 or 1? 0. 1 or 0? 1. 1 or 1? 0. So what is 1, 0, 1, 0? Go back and check out. 1, 0, 1, 0 is clearly nothing but 10. So therefore, at the end of this operation, x got back to 10. So just check out initially how did we start? We started with x value as 5 and then we started with y as 10. But at the end of this, exclusive OR operations, a series of exclusive OR operations, we remained with x value as x value as 10 and y value as 5. So this is the way in which the numbers are swapped. These are the three possible ways in which you swap your numbers. So dear students, I will now show you how to execute this code. But remember here, I'm just reading the values once. I'm only reading the values once and I'm just using the same values to get the job done. So after when we put this into code, so Alt F save, Alt C compile, and Alt R run. So when I run this program, enter two numbers. Say for example, I put in the two numbers 5 and 10. Please check out carefully. I'm doing swapping of two numbers. Initially, before swapping, A value is 5, B value is 10. This value is taken by next step. So using the third variable, A becomes 10 and B becomes 5. Now the recent modified value of A is 10, B is 5. So when A is 10 and B is 5, if you swap it, A becomes 5 and B becomes 10. This is using without using third variable. And before swapping, A is 5, B is 10, using bitwise operators, A becomes 10 and B becomes 5. So this is how you can run your program. If you want to check out, you can check out for any other number. A is 34, B is 89. Okay. So this is how you swap. Okay, so this is what it happens. So now I request all of you to kindly take a pen and a paper and try to do it all by yourself. Okay, so try writing the code. Good day.